Hey guys, welcome back. So today I brought home this 3500 watt Powermate generator, and as you can tell by looking at it, this generator has had a very rough life. Now, the person selling this didn't say too much in the listing other than it has a good Subaru engine and the generator head makes very little power. So I didn't ask too many questions. He was only asking $50, and that Subaru engine is worth every penny of that. So before just tearing that generator head off, I do want to do a little bit of testing just to make sure that it is terminal. So I'm going to get you set up a little bit better. We'll check that oil real quick, and I want to get it started, see how little power it's making, and then go from there. Yep, plenty of oil. For this test, I have the light hooked up as well as the kilowatt. So assuming we get some power, that light should turn on. And if it does, we'll check what the voltage is on the kilowatt. And then we'll try applying a fairly light load with that drill. Well, the good news is the engine starts and it does sound healthy. The stator, on the other hand, I was expecting low voltage output, meaning maybe enough to turn the light on, but not too bright. But we got nothing. So that generator head is not even trying to power up. Most likely it's terminal. So let's get the gas out of the tank. We'll get the tank out of the way, and then we'll run some tests on that stator. Yeah, I wouldn't call this stuff fresh, but it's not bad. Not quite. So I filter it with a coffee filter, mix it with fresh stuff, and usually just burn it in my car sooner than later. So this here is what I'm after to do the tests that I need to do on this stator. It's a quick disconnect, and by removing it, you're completely isolating the coils from this control panel. And in order to get accurate readings, you do need to isolate those coils, or else the tests might be suspect. In order to do these tests, you will need a multimeter set to measure ohms and test the resistance of your meter by touching the leads together. In my case, my meter comes in at 0.1 ohms, so any readings I get, I can subtract that from it to get the true value. Now, this connector only has 5 pins, and that makes sense because we have 2 legs and a ground wire. And if you look at the colors here, we have a green wire going to the center pin, and then we have 2 black wires on this side and 2 white on that side. So if I had to guess, I'd say if we tested between a white and a black wire, that would give us the reading for leg 1, and between these two, leg 2. So let's give that a try. And we get nothing there. Let's try the other white wire. And we're at 0.6 ohms, which doesn't seem that bad. 0.6, 0.5. And you subtract that 0.1, it's closer to 0.4. So that's actually pretty good. Let's try the other leg. And it's the same. So that actually looks pretty good. The next test we can do is to just check each leg to ground. So I'll hook up to one of these black wires here and touch the other probe to ground. There's no connection. We'll just double check. We're good. Then we'll check the other leg. Nothing to ground. We're good. And the other test I think we inadvertently did is to just check between the two coils to make sure there's not a connection. So we'll just do that again just to make sure, but we'll test between leg 1, black wire, and leg 2, the black wire. And there's no connection. So it would actually seem that this stator is good. Now, this is a low voltage test, but it usually does catch major problems. And I've actually never had a generator that doesn't make power that this didn't catch. Now, I do have a high voltage tester. We can pull that out if we need to, but I'm fairly certain, based on what I'm seeing here, that this stator is actually good, and most likely we're dealing with an issue with the brushes or the bridge rectifier. Now, there's no easy way to access them. You actually have to remove these stator bolts to get this end cap off in order to access those things. So I think that's the next step. Yeah, I misspoke earlier. You can actually test the brushes right here without removing this end cap. So this cover here just pops out. There's no fasteners holding it in. And once it's out, you have access to the brushes, but I don't see any brushes. Well, that is a problem. I can say 100% without brushes, this will not make power. And not only does it not have brushes, but the wires that the brushes connect to are missing. So potentially that bridge rectifier is not present, or the wires just fell in. But clearly someone's been in here, they removed the brushes, if not the entire bridge rectifier itself. So this end cover definitely has to come off if we have any chance of fixing this. I didn't see this one coming. Usually these are brushed, but in this case it is brushless. If you look at the rotor, there are no slip rings, and instead we have a capacitor mounted down there. So someone's definitely replaced it at some point, judging by the electrical tape wrapped around it. So I'm going to pull the rest of that tape off. We'll separate that capacitor, and we'll test the excitation winding, make sure that's good, and then we'll test that capacitor. I don't know what the resistance should be on this, but usually on an excitation winding, it's between 1 and 1.5 ohms. And that's a little higher than I usually see, but you know, it might be okay on this one. Let's check it to ground. No issues there. And I'll check it to the other legs, leg 1 and leg 2. Testing the leg 1, no connection. And leg 2, no connection. So it would seem that this coil is also good. Let's check that capacitor. And there's the rating. It is 5 microfarad plus or minus 5%. Now, most likely this is discharged because it was connected to the coil, but it's always a good idea to double check. So I'm just going to short this out with the screwdriver to make sure. And we're fine. And that is a good capacitor. We're at 4.97 microfarad, which is pretty much perfect. So I guess a minute ago, I thought for sure I knew what the problem was when the brushes weren't there. But now we know it's brushless. The capacitor is good. It seems like the excitation winding is good. Really, the only thing left to test is the rotor. And if that doesn't show anything, I think I'm going to have to break out the high voltage tester. And finally, we have the rotor. These are kind of hard to test on a brushless generator because there are a few components in circuit. In this case, we have 2 varistors on either side, and we have a diode. You can just see it right there. It is black, so it's kind of hard to see, but this is one of the wires going into the diode, and then about 1 inch in is where the other lead comes out. Now, assuming all these components are good, the resistance should be very high, like in the millions, if not infinite resistance. So if we touch the probe leads on either leg of this diode, we should get approximately the ohms reading that this coil is at. So I don't know what the resistance should be, but on brushless generators, it's quite low. I've seen them as low as 1 ohm and probably as high as 20 or 30 ohms. So let's assume these components are good and see what the ohms are at. $15.7 ohms. That seems good. There's no smoking gun on this Powerhead. So far, everything has come back good. Really, the next step would be to cut the diode out of circuit and test the diode, because if the diode is not functioning as a diode, then the rotor will not power up, and it's not. So logic would say, let's cut the diode out. But this rotor does not have permanent magnets. So there is a chance it just lost magnetism, and there's absolutely nothing wrong with anything. So before I cut that out, I think I should put it back together. We'll start it again and try flashing the field to see if we can't get this to power up. But before I do that, since I have everything open, I'm going to get out the high voltage tester and just make doubly sure that all the insulation is good. For these tests, I'm going to use this insulation tester. It can send voltages into the windings up to 5,000 volts, but for this test, I'm just going to use the 500 volt range. That's more than double what these coils will ever see. So I've got one lead connected to the bell housing down here, just as a source of ground. And the idea is I want to check each leg 1, leg 2, as well as the excitation winding, and just make sure the resistance between the coil and the ground is very high. So we'll check leg 1 first. And we're already at 300 million ohms, no issues there. We'll check leg 2. Same thing there, we're already at 300 million ohms and climbing. So leg 2 is good. Now we'll check the excitation winding. No issues there. We're at 500 million ohms and climbing. So there's no faults to ground. Let's check each coil to the adjacent coils. All right, I'm going to start by testing between leg 1 and leg 2. And we're at 400 million ohms and climbing, so that's good. We'll check between leg 1 and the excitation. No issue there. We're already at 1,200 million ohms, so that's quite good. Now we'll do leg 2 to the excitation. And no issues there. We're at 600 million ohms and climbing. So there is no insulation failure in the stator. Let's check the rotor. For this test, I've got one lead clipped on that wire on the diode, and we'll touch the other to a ground on the rotor. And no issues here. We're already over 600 million ohms and climbing. There is no issue with the insulation on the stator or rotor. I think that just proved it. Now, I don't know what good ohms values are for any of these coils, but nothing is shorted. The insulation is fine. I would say we don't have an issue here. The capacitor is good. So there's only 2 reasons left why this can't power up. Either we have a bad diode on that rotor, or we lost residual magnetism. So I think the least destructive thing to try at this point is to put the cap back on, connect everything back up, we'll start it again, and we'll try flashing it, see if we can't get it to come back without cutting that diode out. It's actually the next day, and despite what I just said, I can think of a third reason why we're not getting power output, and that is that we are getting power output, and there's actually an issue in here in the control panel itself. So I did reconnect this to the control panel and checked the resistance from the outlets of leg 1 and leg 2, and the readings I got matched what I got when testing directly. So that pretty much eliminates a wiring issue, a circuit breaker issue, or an outlet issue, and we're kind of back to the other 2 options I was talking about a second ago until I went online and looked up this capacitor. This clearly is not the correct part because the guy before me covered it all in electrical tape to insulate it properly. So I wanted to see what does the correct part look like. And I was able to find it, and it looks pretty much just like this, except there's no wires here. Instead, there's just these spade terminals coming right out the top of the capacitor, and the excitation winding just connects directly onto those, and then no need for electrical tape. So I was thinking of ordering one of those just to make it the correct part, and then it hit me. There was a picture of the correct capacitor, and it was hard to see the microfarad rating because there was actually a watermark over it, but I could see the number 2, which didn't make sense. So I thought maybe that was just a stock photo. So I Google searched the part number and found on multiple sites that, yes, in fact, it should be 22 microfarads for this generator, not 5. So although this tested well, I think my mistake was trusting the guy before me had put the right part in there, and clearly he didn't. And that alone would absolutely keep this from powering up. Now, I guess the question that I have to ask myself is, why did you replace it in the first place? Obviously, it had stopped making power, so we could still have a diode issue, but I would say 100% we have a capacitor issue. So I have ordered a new one. It's going to be a few days before it gets here. So while waiting for that, I'm going to do a few basic tune-up items. We'll get the oil changed and clean up that carb. I was kind of debating whether I wanted to clean this carb or not. I mean, it did run the engine for the 10 seconds I ran it. Granted, it didn't sound perfect, but it did a better job than most. Anyway, I'm glad I did, because I just pulled the drain out and let the bowl drain and was kind of surprised to find this in the bottom. You know, that line down there, that is water that is saturated with rust. Nice. The main jet's right there. This is probably one of the smaller main jets, and this brass breaks really easy. So if it doesn't come out, I wouldn't force it. But let's give it a try. Oh, got it. And I believe the emulsion tube is removable on this one. And the only thing left here on the top is the pilot circuit right there. All right, and that's it. It's not much to these carbs. We got pretty lucky with this one. Everything came out. Throttle plate is not stuck. So this should clean up pretty well. The rust, you know, it is what it is. The cleaner isn't going to help with that. And this bowl, yeah, probably am not going to use that. I actually have a carburetor from a Subaru EX21 that I couldn't save because the throttle plate was rusted in place. And that one had a bad bowl too, but I let it soak in evaporust for a few days and it cleaned up pretty well. So I'll try to clean that up, but most likely that needs to soak in evaporust. And instead of waiting, I'll just grab that other bowl. It's actually cleaning up pretty well. And in case you're wondering, that is the secret sauce I use in my ultrasonic. It is made by Harbor Freight. It is their super heavy duty degreaser. It is concentrated and it's not flammable and non-toxic. So I prefer using this just over some of the other alternatives. It works pretty well. It's always a good idea to test the function of the needle and seat. Now this one was working before I cleaned it, but sometimes when you put it together, it doesn't quite go together the way that it should. So like this, it simulates a full bowl. And when I blow through this line, you should hear no air. If you hear something, it's gonna leak. And we're good. Done. New capacitor showed up today, and it seems to be the right part. I got 22 microfarad on the label. And, you know, when ordering online, it's really hard to tell sometimes the scale of what you're ordering. And I thought this was the same dimensionally as the one that was in there. But now that it's here, you can see there's a pretty substantial difference. So I was a little bit worried that it wasn't going to fit, but it lines up perfectly with that hole, and there's plenty of clearance. So this should be fine. Let's just double check that it is in fact 22 microfarads before installing this. Now this capacitor can be plus or minus 5%. So anywhere between 21 and 23 microfarads should be fine. And we're at 21.7. That's perfect. Place your bets. Nice. I've got to be honest, when I bought this, I was not expecting that this stator would come back. I've picked up a bunch of these Powermates that don't make power, and pretty much every single one has been terminal with a bad stator. And that's not the case here. I mean, obviously, the stator's fine, the engine's fine, and that's good and bad because I may not have bought this if I had known this was a viable generator, because now we have a good engine and stator, but the rest of this thing is a mess and needs quite a bit of work. So I think the next step here is probably to test this a bit longer. Just make sure there's no surprises. And if everything continues to run well under load, then I think I need to get this back in, get the engine and stator uninstalled from the frame, and try to improve on what's going on here. Not too bad. It started first pull, and the engine sounds pretty good. It is running a touch lean, but I guess that's to be expected without the airbox. I'm not too worried about that now. As far as the voltage goes, it was high, 129 volts, and the engine speed was at 62 hertz. Usually, I like them closer to 61.5, but I think we're in the ballpark. Now, this doesn't have an AVR, so it is normal to see voltages around 130 volts without a load. And loaded up, to 3,000 watts, which is close to the max that this is rated for continuously. The engine speed held at about 58.5 hertz, and the voltage dropped to about 118 volts. So I would say the engine's doing fine. You know, it's not down on power. It is lean, but again, we'll just wait till we get the airbox. You know, I have the information I need. You know, the Powerhead has no issues delivering the power, neither does the engine. So that means I need to get this back inside and see if I can't clean up this frame any. It took quite a bit longer to get these off than I expected. I'd say about 15 minutes in total. And the reason for that is that the bolts that were used were way too short. And instead of going all the way through, the nut was actually in there. And it was impossible to get a wrench or pliers or anything on that. So I ended up just using the right size drill bit, kind of wedged it between the frame and the nut, and got it to lock the nut in place, and then finally they spun off. Anyway, we're in. You know, the frame is bare, so I'm going to attack this with a flapper disc and just knock all the rust off that I can. I mean, this is never going to be perfect, even if the frame is made perfect, because there's overspray on everything. You know, it's on the tank, it's on the recoil, it's on the control panel, and I'm not going to be able to clean up everything, but we'll at least get the frame squared away. We'll get everything proper, and I'll clean up the rest the best that I can. So for whatever reason, this generator is missing its feet, and instead installed were these two pipes bolted together right there, which honestly does not work very well, but I guess it's better than nothing. Anyway, I do have extra feet. I think the ones closest to fitting this frame are from a Predator generator. I have two of these. They're meant to be mounted like this, but as you can see, they don't fit. So I'm going to install them like that. And I want to drill those holes out first before painting this up. Going to use a Dremel to take a little bit of paint off here. This grounding wire needs to have a connection to the frame. Things are coming together pretty well. Those Predator feet are perfect for this generator. The frame is sitting nice and level, and those wheels, I did end up going with a longer bolt that goes all the way through. So the reassembly was quite a bit easier, and that also corrected a negative camber issue that I had on those wheels. So really not much left now. It's just the handle, the control panel, and the tank. Now, when cleaning the frame, when prepping it for paint, at one point I did put some alcohol on to clean things up, and I noticed a lot of the blue paint, like the overspray, came off with the alcohol without damaging anything else. So there is quite a bit of overspray on the tank and a little bit on the control panel. So I'm going to try a bit of alcohol. Maybe we can get that cleaned up and looking a little bit better. Perfect. Put a bunch of that alcohol in a spray bottle. So I'm just going to spray this down and see if I can't get it off. Anyway, you get the idea. It's coming off pretty well. I mean, it's not going to be perfect, but it'll be much better. Well, guys, that is pretty much it. I mean, this generator was a complete mess, and now it actually looks like someone may have cared for it. But as tempted as I am to wrap things up, I can't. You know, I am still missing one major piece, and that is the airbox. It's actually been 3 weeks since I started filming this video, and the airbox I ordered from Amazon for $40, it never shipped. Amazon actually canceled the order. So I went to eBay, found another one for $10 more. So that order's been placed. I think the only catch is it's shipping from Israel. So it's going to be a few weeks before I see it. So I'm going to hit pause here, turn you back on in a second. We'll get that airbox installed, and then I want to bring it out and run it one last time. The paint on the exhaust does need to get up to temperature to fully cure. It's been a total of 6 weeks, and the airbox is finally here. Now, this is not an OEM airbox, but it looks like it will be compatible. And, you know, Subaru parts are expensive, which leads me to the next problem. I don't have a gasket for between the airbox and the carburetor. So, you know, a gasket set is available for $22. So I can make one virtually for free. And I already have a template from a previous project. So I'm going to use this. We'll transfer that over to some gasket material and just cut it out and then finish this thing up. The outer edges here do not need to be perfect. Really what counts is these holes and these notches here. They need to line up so that the gasket goes on centered properly. This is just a parts carb, but it is the same carb that's on that engine. And this carb's no good, but still serves a purpose. I can double check this gasket, and you can see we're pretty close. I think this is the only part that's a little bit off. I just got to move the hole for the stud just a touch further out. That should do. There is a small difference on these boxes. The breather on the old one goes in on the side, whereas the new one, it goes into the back here. And I mean, I could make that work, but you know, I've already checked the filters and the cover for the new Airbox fit on this old housing. So I think I'm just going to clean this up a bit. I'll reuse the old backing and just put everything new on the front. Gotta put this filter in dry, but if it's still running lean, I'll add a little bit of oil to it to richen things up. To be honest, I did not give this one much of a chance. You know, I bought it for the engine, and generally, if a generator is not making power, it's terminal. But in this case, the guy before me just used the wrong part. You know, once that capacitor was replaced, the Powerhead came to life and is doing a good job. And so is the engine. You know, the addition of the Airbox definitely richened it up a bit. I think just enough. And, you know, the frame, I mean, what can I say about the frame? It was a disaster. Had a lot of hardware missing, overspray, rust, you name it. But now it almost looks like someone took care of this. So, I hope this video helps someone. Thanks for watching.